Well, another Sunday just after midnight has arrived for you guys, and I want to give you this is part 2 of the A6 Electrical Systems Simple Practice Test, part 2. And so I don't know, this camera that I'm using is not a regular webcam. It's basically like a $500 handheld video camera that I used for years to make my videos at the college. And so I mounted it on a little thing here where it shoots past the monitor, and it gives better images than most webcams do, than most webcams I've seen. Anyway, the only problem with it is sometimes it tints the video a little yellow, like you see right. I don't know what the deal is with that, but you can still see my face anyway. Let's start on this test, see what we do. Question 1. When tracing a short or an open, a smart technician will check which points first. Will they check those nearest the load, those nearest the ground, those nearest the power, or the ones that are most easily accessible? Most easily accessible. I have a tendency to be sequential in my thinking. I always like to think from either from power toward ground or from ground toward power. And there's been times when I went to more trouble than I should have by trying to check, well, I'm going to check from the power, and then I'm going to check to the next point, the next point, the next point, and then I'd find the problem was in a big connector right up there on top of the engine that was easy to get to. And so I was thinking, I would have been smarter to go ahead and check the easy places first. And that's an easy trap to fall into if you're a sequential thinker. There was a computer programmer, guy was a computer science major that I knew though, and his name was Roger. He's a little bit older than me. And we used to do target shooting with our pistols down at the clay pit. We'd set up bottles and cans down there and shoot at them. And it was funny to me how I always wanted to take, when I was taking rounds out of the bullet box, I would like to start at one corner and take out the first 5, put them in there, leave a chamber empty for safety and all that, and then blast away 5 times. Then I'd put those empty casings back in there for reloading, because I reloaded them, and then I'd pull the next. Well, when I would hand him a fresh box of shells and hand him my pistol, empty, I'd say, go ahead and load it up and bust off 5 shots, but don't put one under the firing pin to start with. He would just reach in the middle of the box and pull one of those bullets out. That just drove me nuts. Anyway, this is actually sort of like that. If you think about, okay, where's the easiest connector to get to? This is what I'm going to start with. Not necessarily, checking power and checking ground isn't a bad idea if you know where those are. But if you're looking for an open connection in a circuit, start at break it in half at the easiest place, and check it on both sides. That's just all I'm going to say about that right now. Question 2. The measured resistance of a bulb lying on the bench is 2 ohms. With the bulb connected to power and illuminated, the bulb's calculated resistance is 6 ohms. Which of the following is true? Was the math done incorrectly? Does the bulb have a bad filament? Is it positive temperature coefficient, or is it negative temperature coefficient? Now, this is your Ohm's law. You can look at this and study it a little bit and figure it out if you're not familiar with it. Now, let's move on here. The bulb is positive temperature coefficient. Intake air temperature sensors and engine coolant temperature sensors and transmission temperature sensors and the others that the PCM uses are negative temperature coefficient, which means the hotter they get, the lower their resistance gets. the higher their resistance gets. Other way. The hotter they get, the less resistance they have. Instead of, but on the positive temperature coefficient, stuff like a bulb, it gets more resistance when it gets hot. It's easy to get that stuff crossed up in your head and say it wrong, even if you know what you're talking about, Question 3. After a 3-minute high charge session, the voltage reading for a 12-volt battery reads 17.5 volts. Does that mean the battery is 2 years old, has 1750 cold cranking amps, needs replacing, or that the battery fluid has turned alkaline? That's going to be the battery needs replacing. The plates are sulfated and it's taking a lot to push, there are some people that will argue one way or another about this, but typically the way it was always taught in all of the electrical schools that I went to at various different, with Mazda and Ford and Chrysler and Volkswagen and all these other schools I went to, Jeep, they typically always, taught that if it's more than 15.6 volts after a 3-minute high charge, and I like to stick a meter on it, my voltmeter, and measure it and turn it over 3 minutes and then come back in a little bit. Some battery chargers will actually have that on their little meter on the front, the bigger battery chargers, and it'll tell you if the battery is sulfated, if it goes off into the red, which is the higher voltage range while you're charging it. So that's basically what that means. Question 4. A waveform displayed on a lab scope is basically a graph of current frequency, time over voltage, amplitude duty cycle, or voltage over time. Well, that's obviously voltage over time. Anybody that's used a scope kind of knows that. I like to get various different little scopes and play with them, and dial the reading. The smartest thing you can do to get good with a scope is use the scope as much as you possibly can. There's a lot of guys that I know that have scopes they won't ever use. They got a scope, but they just don't use it. And I think I mentioned one time about that guy from Pennsylvania that contacted me and said that he had this vehicle that he was working on. I remember what it was, but down there when he was replacing the timing belt, a bolt broke off, and it was one that had to be fixed, and he was struggling with that, and he fought with it, and he used a torch a little bit, and he finally fixed the bolt and got the hole rethreaded and all that kind of thing. It took him a little bit to do, but it was down close to the bottom of the engine. And he said after he got through with all of that, whenever he'd spin it over, it would backfire, and it would even sometimes it seemed like it was firing in the crankcase and do all kinds of crazy stuff. And he was asking me about it, and I says, look, scope the cam and the crank sensors and see what they look like. You know what they're supposed to look like. So go ahead and scope them, or you can find on IATN a known good scope pattern for that particular engine. And 3 weeks went by or something like that, and he still hadn't found it. And finally, whenever he sent me the solution, he said, I finally connected the scope, and instantly I saw that I had, while I was working on that bolt down there, I broke one of the teeth off of the cam sensor or crank sensor tone ring. So he had 2 wide gaps in that thing, confused the crud out of the PCM. Not every PCM is going to react the same way, but that particular one was just crossfiring all up a storm and making all kinds of issues. Question 5. Higher than normal current flow in a circuit could be caused by A, a burned out LED bulb, B, motor winding issue, C, poor ground connection, or D, undersized power wire. Typically, and that's going to be a motor winding issue. But even if a circuit is worked right the way it's supposed to, you can take your scope and your current, look measuring current, and if you've got a scope, as soon as you turn on a load like a motor or a bulb or just about anything, it's going to spike up and then it's going to go down. Which is, this one here is actually showing a higher load, but the one that preceded this, that you could pause the video on the previous slide, it'll spike up and then it'll come down and it'll level out. So if you've got, for example, a set of bulbs that are pulling, that parallel wired, that are pulling, let's say, 15 amps, if you put a 15 amp fuse in there, you're probably going to blow the fuse about half the time when you turn on the lights, but you're going to need to put a 20 amp fuse in there to absorb that spike when the load first happens. That's just how that is. Question 6. Each cell in a healthy automotive battery produces 1.5, 2.1, 2.6, or 12.6 volts. All right, the right answer to that is 2.1 volts. That's what you're going to get. So you can do the math, 2.1 times 6, that's how many volts you got in your battery. Question 7. The red brake light comes on when the key is in the start position, remains on for the first 2 miles of driving before it goes off. Well, when you're going to your start position, it's going into a prove out, typically. Okay, after first couple of miles of driving, it goes off, and you're looking at a low brake fluid situation. Now the reason the brake fluid will get low as the calipers fill up with fluid and the pads wear, the fluid in the master cylinder is going to go down, and then you're going to need to add some more. So as the fluid expands with engine heat, it picks that little sensor up off of there, off the bottom of that thing, and that's basically how that works. All right, we've been here nearly 10 minutes and we got 3 questions left. Question 8. Which sensor creates its own voltage signal? The ECT, the O2S, the IAT, or the MAP? The answer to that is the oxygen sensor. It creates its own voltage signal. A conventional oxygen sensor is a zirconia style. As it hits about 600 degrees, it starts creating voltage. Now you can demonstrate this. I had a cutaway catalytic converter that had an oxygen sensor port in it, and I would put it on this big piece of wood, and I would connect a voltmeter to the 2 wires that are the same color, the heater wires. You don't want to connect to those because you're wasting your time. But you want to check the voltage. Typically on the black wire will be where your voltage is. So between there'll be a gray one and a black one, or then there'll be 2 white ones, or there'll be two that are the same color that are going to go to your heater. They'll have about 6 ohms resistance if you check them. Let's say you want to check an oxygen sensor. Screw it into that thing, or you can put it in the vise or whatever you want to do, and take your meter and hook it up with reading the volts on the black. Typically it's going to be the black one coming out of that sensor, and then give you a bottle torch, like a propane bottle torch, and just heat that sensor up, watching that voltage, or you can put it on a scope, and you'll start seeing that thing gain voltage. It's better to do it on a scope. I like doing it that way. And then as you sweep that torch back and forth across the bulb of that sensor, once you get it hot enough to start producing, you'd be amazed how fast that sensor reacts to that torch pushing the oxygen away from that bulb inside that cage. But the voltage, you don't have anything connected to it except your meter, and it's creating its own voltage as you heat it up, because that ceramic zirconia isn't sort of an electrolyte thing. Question 9. A customer checks the battery with their little battery tester because of a slow crank no start on a seldom driven low mileage 2016 F-150. What's the next best step with this reading that you see right here? This is an actual reading. Replace the battery, full charging system test, starter voltage drop test, or recondition the battery and test it again. I want you to watch this. This was my wife's truck. Doesn't get driven very much. Periodically I'll go out there and check the battery. I checked the battery and I got this reading right here, and I said, oh no, this is terrible. And the battery's not all that old. The battery's only been in there a couple of years, and the truck hadn't been driven very much. And so I got this Viking $60 battery charger from Harbor Freight. You can laugh at Harbor Freight all you want, but I used to tell my students, if I was just getting started in this business, I would stay off that dadgum Snap-on truck and I'd hit Harbor Freight real hard. But anyway, I bought this battery charger, didn't even pay a lot of attention. I just wanted a small battery charger. And I noticed it had this condition thing, function on it. And I mashed that, and it said battery in repair now. Now I left it there for several hours, because the truck didn't need to be driven. It was sitting in the garage anyway, and it was easy to, no matter what the weather was. And after I did this battery repair with this little Viking thing, I tested it again with it, and it came up really, really good. My son had a battery on his he's got a 96 Chevrolet pickup that he uses to haul stuff, but he don't drive it very much. And the battery was reading. I gave him a battery tester similar to this one. And he said he tested it, and it basically, the state of health on the battery was like 16% or something stupid like that. And so he ran this battery conditioning on this, and it brought it up considerably. And then he put a 2-amp charge on it and let it stay on there for a couple of days, and it brought that battery up to where it was a completely, totally healthy battery according to that little tester. So that little cheap battery charger, for home use or whatever, is really, really a good thing to have, or one that's got that function on it that says recondition, and it'll straighten one out, because it got my wife's truck. if you just checked this thing and you didn't, you could hook it to a slow charge and probably do something similar to this if you just put it on a 2 amp slow charge for a long time. But anyway, I had fun with that. Question 10. Back probe in a throttle position sensor shows a full 15 volts on all 3 wires. This typically means that it's got an open TP signal wire, an open TP signal return, TP signal short to ground, or a VREF circuit wire open. Alright, watch what I did for you here. Watch this little diagram here. It's a live diagram. Alright, you're going to get the answer here in just a minute. See how that TP sensor is going up and down? Voltage is changing. This is reference voltage. That's your signal return ground. Alright, now what we're going to do is we're going to turn off the key and we're going to cut the signal return wire, just for the sake of argument. Now look, all 3 TP sensor wires now have equal voltage. I've seen this. And it can be a problem in the sensor, it can be a problem in the PCM, it can be a problem in the harness. On some of your old cars, whenever something would go wrong with the signal return circuit and they didn't want to spend any money on it, I would just take the signal return circuit for all the sensors, and that signal return goes to every sensor on there. Reference voltage, straight reference voltage only goes to 3-wire sensors, but a 2-wire sensor will always have a signal return ground. And I just tied into that signal return wire, which is spliced out and goes to every sensor, and I'd ground it directly to the battery. And that would get that car going again. Come in as a no start, find out that it was all the sensors are reading pretty much reference voltage. Of course, on your 2-wire sensors, it'll read. This is actually a little too much voltage, 5.8. My little voltage regulator I put in my diagram wasn't quite, it didn't work quite right, even though it was supposed to. Anyway, I hope that gave you a little bit of insight on that you didn't have before. This is going to be different, so watch that. Some guy grabs the tools and the rag and takes it away. Then we're ready to go to work. You guys have a great week. Let me know what you thought about this. Share it with your friends, and I hope it gave you a little bit of insight in some areas that you didn't have before. I'll talk to you next week.